Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 24th, 2025, about 2 days ago. It introduces a compact reward model that helps information-seeking agents plan long, multi-step tool calls, and in tests it boosts smaller open models by about 9% so they can match or even beat much larger frontier-style systems. The paper is titled PRInTS, Reward Modeling for Long-Horizon Information Seeking. And as we will see later, its mix of information gain scoring and trajectory summarization has surprisingly broad implications for how we guide agents at test time. Alright, Figure 1 contrasts how previous process reward models behaved with how the new approach works. The left panel shows that raw reasoning context balloons with each tool call, while short summaries stay compact, which keeps evaluation manageable. The central diagrams illustrate that older reward models only give yes or no scores on tiny reasoning snippets, whereas the new model scores full steps and maintains an evolving summary. The right bar chart reports that this richer guidance significantly boosts QN 332 billion performance on the GAIA benchmarks. Well, Figure 2 turns that high-level idea into a concrete workflow. The figure shows the reward model sitting between the agent and its tools, scoring several candidate next steps and then picking the best one. The left side illustrates step-level information gain estimation, where each candidate action gets a written analysis and a dense numeric score. The right side illustrates information-seeking summary generation, where the same model keeps updating a compact trajectory summary, so the context never grows out of control. Alright, Figure 3 dives into how the authors actually train this reward model. The top panel walks through trajectory score annotations, where Monte Carlo rollouts estimate how much a given step changes the chance of a correct final answer, then turn those scores into winning and losing preference pairs. The right side of that panel shows training as a scorer, with separate rewards for accurate information gain prediction and for preferring better steps. The bottom panel explains trajectory summary annotations, where each step receives a compact, updated summary that the same model learns to generate. So after training details in the previous figure, Table 1 shows how different step scoring methods affect the QN 332 billion agent. The table reports average accuracy across frames, GAIA levels, and WebWalker QA tiers. The base agent sits around 30%, and simple confidence or relevance scoring adds only a few points. Strong baselines like GenPRM and WebShepherd still hover near 32%. PRInTS jumps to about 39% on average, which marks a large and consistent improvement across all benchmarks. So while Table 1 showed gains on a standard open model, Table 2 shows what happens on the specialized deep research 30 billion agent. The base agent already scores about 63% on average, which is quite strong. Simpler scoring rules like confidence or relevance fluctuate around that mark and sometimes hurt performance. Stronger baselines, such as GenPRM and WebShepherd, also land near 63%. PRInTS still pushes the average to about 67%, so even a highly tuned agent benefits from this richer step evaluation. Okay, while Table 2 focused on a specialized open agent, Table 3 shows how the same reward model behaves with the frontier system Gemini 2.5 Flash. The base agent averages about 40% accuracy across the GAI levels. Traditional scoring tweaks like relevance, verbal progress, or WebShepherd only nudge that to around 41%. GenPRM actually drops performance slightly. PRInTS instead reaches roughly 44% on average, with especially strong gains on the hardest Level 3 split. Well, Table 4 shifts the focus from raw accuracy to how context is fed into the reward model. The table compares using the last 1, 2, or 4 steps, or the entire history, against the learned summary. Raw histories either underperform or plateau, with full history averaging around 40%. The summary-based input instead reaches about 47% on average, and clearly wins on GII Level 1 and Level 2, which shows that compact, curated context leads to more accurate step scoring. So, the big takeaway is that a small, generative reward model can smartly score each step and keep its own summaries, which lets even mid-sized agents rival frontier systems on tough information-seeking tasks. More broadly, this shows test time guidance can substitute for expensive full model retraining. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.